Okay, welcome back. We're in the midst of using the index of thing. So now that I have this index, I'm going to do a loop, and we already talked about what kind of loop it should be. I'm going to say while index is greater than or equal to 0. In other words, it's not a -1. Okay? And it is possible that it won't run at all, right? If I was hunting for kumquat, it's not going to find that in Mary Had a Little Lamb at all. So therefore, the low line 40 is not going to run. So this is the appropriate type of loop. Okay, so now that I got that, what do I basically have to do? Well, I'm going to go ahead and spit out I'll tell you what I'm going to do. I'm going to take this and move this line inside here. And maybe make it a little bit more sophisticated, like, you know, found it at or something like that. Okay, cool. And then I want to search for, again, in case Mary exists more than one time. So I would say index is equal to poem index of Mary. Now, can you look at this for a minute and see that there's a problem with this? Can you figure this out? Can you see what might happen here? Let's just run it to make sure what you're seeing is what you think you're seeing here. And it runs forever. It's an infinite loop. I'm going to have to stop it. Why is that? Well, because I told it to find the first one, and then I told it to find the first one, and the first one, and the first one, and the first one, and so it'll never stop. What I need to be able to do here is to tell it to skip past that previous location and look somewhere else. I found it here, now move over one and hunt there, okay? So in this case, I'm going to say index plus 1. In other words, wherever you are, scoot over one and then do it. So let's try that again. This ought to work a heck of a lot better. And it found it at 0 and 75. Hey, let's put in something that happens a lot, like A, the letter A, okay? Dang. Come on now. Dang, what the heck is going on here? Somehow I'm in the... Okay, now, there's going to be an awful lot of these, right? No? You got to be kidding. Oh, ha ha ha. I have to put it in both places. If I want this thing to work, I'm going to have to put Mary in both cases. I mean A in both cases. Okay, yeah, here's a bunch of these guys. A shows up a whole bunch. Okay, that kind of makes sense? Okay, good. Now, let me tell you a little trick. Remember how you found it at the end, and then you add one? Well, oddly enough, let's say that the last thing in this string was the letter A. In fact, the last thing in this string is a dot. Okay? So let's just do that. I'm going to use dot here. And then put a dot here, okay? Now, if it does this, that means that this index plus 1 is going to be outside the range of the string. In other words, if the string is 50 characters long, I'm going to be asking for the 51st location. So you might think, oh, well, that's going to blow up. I mean, there's no way the machine's going to be able to figure this. And what? How did it work? I mean, I asked for something that doesn't exist. How come it didn't throw an exception? Well, they just cut you some slack. It is perfectly okay for this second parameter to exceed the length of the string. They, instead of, cracking the whip and saying, no, you made a mistake, they basically said, okay, look, whenever you do that, we're just going to return a -1 because it just makes life easier. Wow, isn't that nice of them? Okay, now let me ask you another question. This is a philosophical question for which I really don't have an answer. Let's say, for example, that you were hunting the string that you were searching. So let's do string search is equal to, let's do XXX, okay? And then the string I'm trying to find is XX, okay? Let's just pretend that. Now, here's a philosophical question. How many matches are there? Is it one is that one, and that one is that? That makes two? So when you're searching for this, does that mean there's two matches? Or does that mean there's one match? And to tell you the truth, I really can't answer that question. Some people want to do like an I'm not even sure there's a word for it, but an inter-string match. In other words, find those things where they're overlapping. Others, when you increment, you're not going to be incrementing by one, you're going to be incrementing by the length of the string. So if Mary, you would increment by 4, okay? Because you want the whole word. So if you were searching for whole words and not things where, I don't know, it's like, I can't think of anything that would work there, but anyway, where there's an overlap. So you just need to be thinking about what does a search mean to you, and how do you solve it if that's a problem. Okay, so back to the lecture for just a second. And so we talked about searching for locations, and it is rather forgiving, which is pretty doggone cool. So the next one is about on page 572. It talks about extracting strings. No, all this stuff was to tell me where it is, but he didn't pull it out. So there's another set of these things that are kind of sort of similar called substring. And substring will go to where you told it and then pull out what you told it to pull out. Now, I will caution you right off the bat that Java does this differently than a lot of other languages. So, for example, when I convert an application from Java to like C#, okay? In the C# world, the second parameter here is the length of the string that you want. But in Java, it's the starting location, and the second one is the ending location. You know, the starting index and ending index. And that drives me nuts. So whenever I convert between Java and C# or C# and Java, I have to find every single one of these dang substring things and then go beat on it with a stick. And I don't like that, doggone it. Okay, so now that I know the index, I can go in and start pulling things out. Cool? That kind of sort of makes sense. Okay, so let's do another one. Let's go here and let's just say, for example, I have no idea what this is, but I want position 100 to 105. Okay, cool. So I'm going to say system out print ln, and it's going to be poem dot, and then I want to do substring starting at 100, ending at 105. Okay, that kind of makes sense. Now, what's that going to be? I don't know. Let's go see what it is. It's re2. Okay, so what I've done is you use index to find out where it is, and then you use substring to extract it if you want to extract it. Okay, that kind of makes sense? Good. Okay, and then one of the other methods they talk about for extracting strings is the to-char array thing. We've already done that. All it does is just takes it and returns an array of characters so you can easily iterate over it like we did. Cool, we already done all that. There's another one called value of on page 577. And what this does is this will create a string representation of some primitive type. It's not very exciting, but it's there. So moving on. The next thing we're going to talk about on page 579 is this thing called a string builder. And before we can even talk about string builder, we need to return and talk about strings. Okay, now this is a deep dive kind of thing, so please pay attention and take notes. All right, let me start. Strings in Java and quite a few other languages are what's called immutable. Immutable. And that does not mean that they can't be muted, because if so, I would have tried that on my wife long ago. I grabbed the remote control and pointed at her, hit the mute button. It don't work. That's the same thing here. This is not what we're talking about. It's not about muting. Immutable means they cannot change. And you're thinking, well, of course they can change. I can assign Bob to a name and turn it right around and change it to Sally, and it works like a champ. Well, yes, but behind the scenes, what the machine has done is whenever you assign two separate values to the same string variable, it actually builds a second string and throws the old one away. I know that sounds crazy, but let's just go through here. Let's just say string, I already got one called search, right? So if I said string, oh, hang on, sorry, I don't need that now. I just say search is equal to kumquat. Okay, behind the scenes, not that you can see this, it built a string and populated it on line 46. And then when it got to line 51, it threw that old one away and built me a new one. Now this action of throwing it away and building a new one is expensive, meaning that it takes an awful lot of resources and leaves memory like Swiss cheese, because when you first start the application, memory is fairly well organized. But if you're destroying objects and creating new ones and destroying objects and creating new ones, the memory is going to end up looking like Swiss cheese, and it's going to cause a lot of problems. So strings are immutable. All right, one more time. What the heck does that mean? That means that behind the scenes, you don't actually ever change the value of a string. It looks like we're changing a value of a string, but we're really not. Okay, now can you imagine in a loop, okay? Let's just imagine. So I'm going to go here, and I'm going to create me just a goofy little loop here. I'm going to do a for loop. So int, I don't know, I sounds good to me. I is less than 10, I plus plus. Okay, so I'm going to go here, and I'm going to say string junk is equal to a blank string to start with. And inside my loop here, I'm just going to keep adding on to, I'm just going to say junk plus equals, remember how that guy works? Plus equals, and then I, all right? And then when I get to the end, it should be fairly obvious what this is going to look like. At least I would think it would be obvious. It's going to be 0 through 9 as a string. Okay, cool. Now, what that did was I created junk, and then it got destroyed and recreated, and then it got destroyed and recreated, and then it got destroyed and recreated 10 times. That is not good, okay? This is horrible for performance. It slows things down, plus you end up with the memory of your application looking like Swiss cheese. So that is, remember garbage collection? We talked about that one time. Is every once in a while, the machine says, hey, wow, man, I need to go find all those unreferenced versions of junk and go whack them. That takes time and energy. It actually slows your machine down. For example, let's say you're in the middle of a critical, like a game or something, a critical part of the game where it's very time sensitive. If it chose that time to do garbage collection, then you're going to have a noticeable lag in your application. It's going to be running along, it's going to go, and just sit there, and then pick up where you left off. That's not very acceptable thing. So having memory like Swiss cheese invites the garbage collection to come in and do its thing, and you really, really, really don't want that. Okay. So I've described the problem. Hopefully you'll be able to describe the problem. So what's the solution? Well, the solution is using string builder. Instead of doing what I just did there inside this little loop, I'm going to do a string builder to accomplish the same thing. And so you might ask, well, wait a minute, we've been doing string concatenation all this time, and you never said anything about it. Well, to tell you the truth, the rule of thumb when you should switch from using the concatenation operator, the plus, and when you should be using string builder is basically, I don't know, somewhere around like 2 or 3 concatenations are okay. But anything more than that, or if the strings are kind of large, well, then you need to switch over to string builder. Okay, we're coming up on the 15-minute mark. You know how this works.